Unit 4, one variable data analysis, 6.3, standard deviation and z-scores. Just wanted to add something at the beginning here from what we did yesterday, or in 6.2. So we talked about outliers, but I didn't give you any guidelines about how to determine if something is actually an outlier. So using your Q1 and Q3, you can determine outliers. So I'm just going to write a little note of that right here. So an outlier can be found, so it's any data point either less than Q1 minus 1.5 times the IQR, or greater than Q3 plus 1.5 times the IQR. And then today we're going to talk about standard deviation. So once we learn standard deviation and you can find it, then you can also find outliers using standard deviation. So it would be any data point two standard deviations above or two standard deviations below. The mean. So those are just two ways that we can find outliers. So let's go on to today. So here's some definitions. So variance, we aren't actually ever going to use variance, but just so you know, the variance is the average squared difference of scores from the mean. The only time we would ever use variance is if we're given the variance, we could then use it to find the standard deviation, because that's what we actually care about. So standard deviation is the square root of the variance, which means it's the average distance of scores from the mean. So yesterday, or in 6.2 when we did the IQR, that showed us around how our data was around the median. Standard deviation tells us how our data behaves around the mean, and that's just tells us how spread out or how close together the data is. So these values allow you to see how close the values are to the mean. So we do have different notation for population and sample standard deviation. And in this case, they actually do also turn out to be different values. So population standard deviation, we use this symbol. And this is our formula. And now don't freak out about this, because I'm actually going to show you a way to do it on your calculator, or you're going to find a way to do it on your calculator without having to type everything in. So that's our population. Our sample standard deviation is a very similar formula. But you can see there's a difference, and that's what makes them actually calculate differently. So if we were to do this manually, we would have to take each data point in our data set, we would subtract the mean from it, and then we would square it. We do that for every data point, and then we would add those all together. Then we would divide by however many there were, and then we would square root that answer. So nobody really wants to do that. That's a lot of work. Similarly here, we would do the very same thing, only we would divide by n minus 1. That's what's going to give you a different answer. So you do need to know whether you have a sample or a population when you're calculating standard deviation, but you're not going to actually calculate it. Your calculators do this. Now, they're all different, so I can't really tell you how to do it on yours, but there are multiple videos out there that can help you. So what you're going to Google is stat mode. You want to learn how to use stat mode on your calculator, and so you're just going to type in you know, my calculator is called a Casio FX300MS. So I would Google stat mode on Casio FX-300MS, and you'll find probably either a user manual or a YouTube video where someone shows you how to do it, but there should be some way there that you can learn how to type in all of your values and find the standard deviation. So you may want to pause this video now and go and do that and try and find that, and then you can try the examples doing it, or you can watch the rest and always go back. Okay, so here's an example. So these are the ages of participants in a school's talent contest. So here's all their ages, and we want to know if it's a population or a sample. They've given us everybody's age, so this is actually going to be a population. All participants, so all ages are given. They didn't in any way indicate that they only took a sample of the people, so we can assume that they got everybody's. And we're going to calculate the mean and standard deviation. Now, if you absolutely can't find the online how to do it, then send me a picture of your calculator and maybe I can help. I have seen lots of them. It's just hard when I'm at my house and you're at your house to show you, so your best bet is to Google. But if you were to Google and figure out how to find population mean, you should have got 16.5. And population standard deviation, you should have got 1.36. So hopefully you can find a way to do that on your calculator. What would happen to the standard deviation if everyone's age increased by 1 year? It's actually going to do nothing. Nothing would change. Your standard deviation is how far your data spreads out around your mean. So in this case, everything would change proportionally, so nothing would actually happen. Your standard deviation would be the same. And then if we want to know which ages are more than one standard deviation from the mean, we could take our mean, we could add our standard deviation, and we would get 17.86. And then if we took our mean and we subtracted our standard deviation, we would get 15.14. Then if we look back at our data, any ages, so greater than 17 and less than 16 are more than one standard deviation from the mean. That's really messy, but hopefully you can write down as you are listening to me. So that's standard deviation. So the biggest thing is to go into your calculator and figure out how to find it. The one last thing we're going to talk about is z-scores. The number, so what a z-score tells us is how many standard deviations an observation, so a data point, is from the mean. So for again, these are actually will be calculated the same, but it matters whether you have a population or a sample because the formula requires the standard deviation, and so you have to make sure you have the correct one. So a population z-score is z equals x minus the mean over the standard deviation, and a sample is the very same, only we use our sample notation. Okay, so here's an example. A food manufacturer makes 2-liter jars of pasta sauce. Samples are tested for how close to 2 liters they are filled. They took 15 samples and they recorded all of their volumes. So this is obviously a sample because it says right in the question they took a sample of. Again, you may want to jot these down or pause for a minute because I'm not going to come back to this. So I'm going to scroll. We're going to determine the mean and the standard deviation. So if you figured out how to do it on your calculator, that's great. If not, go back and try this again once you do. But you should have got X bar was 2.01467 and sample was 0.0716. Now, I kept so many decimal places just because these are really small differences, so I want to keep lots of decimal places. I'll try in assessments to tell you how many to keep. So we want to know, what is the Z score for a jar filled to 1.98 liters? So we're going to use our formula. So Z equals X, which is 1.98, because that's what they gave us in the question, minus X bar, which we just found was 2.01467, over S, 0.0716, and that equals negative 0.4842. So what that tells us is that that particular jar that was filled to 1.98 liters is below the mean by 0.48 standard deviations. Last but not least, what volume is 1.5 standard deviations below the mean, as any of these would be rejected? So now we're trying to find, if we want negative 1.5 standard deviations below the mean, we need to find what X value makes that happen. So we would rearrange and solve for X, and we would get X equals 1.91. So that means that a jar filled to 1.91 liters is actually 1.5 standard deviations below the mean. And this is something that might be used for quality control. Okay, so that's standard deviation and Z scores.